Welcome back, all my aspiring mathematicians. Raise your hand if you don't know how to factor a quadratic expression if your leading coefficient is greater than 1. Guess what? Don't worry, I won't judge you. I'm just here to simply break it down for you so that you can choose any of the two methods that I'm about to show you. Now, what is a quadratic expression? So a quadratic expression is always in the form of ax squared plus bx plus c. This is in the standard form, but sometimes a is not equals to 1. So if a is not equals to 1, you can still factor that using the grouping method or using GCF, or you can also factor this out using the quadratic formula. Now, I always steer my students away from using the quadratic formula, but in this case, the problem that I'm going to give you, you don't need to use the quadratic formula. Now, A is our leading coefficient, and we have B and we have C. Now, C is always finding the factors such that when added, is going to give you the B term. You're going to apply that in our example that I'm going to solve for you today. So let's get right into it. So my first equation is 3x squared plus 7x plus 2. You'll notice here that your A is not 1. So your A here, A is equals to 3, B is equals to 7, and C is equals to 2. So the first thing that you're going to do with this type of problem is that you are going to multiply your A with your C, and you're going to get 6 in this case. So when you multiply your A with your C, you're going to rewrite the expression whereby you're going to rewrite the first term, or the ax squared, and you're going to also rewrite the C term. But you're going to use the grouping method now. We need to compose this so that we end up with 4 terms here. So we're going to look at the 6 when we multiply A with C. This is the 6 here. We're going to look at that 6. So find the factors of 6 such that when added, it's going to give the middle term. So we have 6 and 1. So we're going to put 6x here, and we're going to put plus x here, which normally we put a 1 in front of it, but we're not going to put a 1 in front of x because we know it is going to be an invisible 1. So now we have 4 terms, and this is where the grouping method comes into play. So what we have to do next with this is that we are going to group them. All right, we're going to group them. So I'm going to write this as a group, 3x squared plus 6x, and I'm going to have my x here, going to put my plus sign here, plus 2 here, because I'm going to group them. I'm going to find the GCF of each of the set of binomials. So we have here 3 as our coefficient and 6 as our coefficient. Here we can choose 3 that is going to go into both of these. So we are going to take out our 3x here. So we're taking out 3x for the first one, and we notice when we take out our 3x there, we're going to be left with x plus 2. And for the second one, obviously we can't, you don't see any GCF there, but what we are going to do, we are going to keep this, but we're going to put a 1 here. So we have a 1 here, and I'm going to keep my x plus 2 inside of that. When you're using the grouping method, right, you must have the same binomial inside the parentheses. If you don't, you are on the wrong track. But if you have the same set of binomials here inside the 2 parentheses, you're good to go. So now what we are going to do, we are going to write this first, right? And I'm going to write my x plus 2. And then what I'm going to do, I'm going to combine what I have here on the outside, my GCF, and put it as another set of term, another set of binomials. So 3x, and because this is a 1, it is a positive 1 and not a negative 1. So it's positive 1 here. This is our factored form of the quadratic expression when a is greater than 1. Now there's another way you can factor this out. I'm going to rewrite the same expression, 3x squared plus 7x plus 2. And the difference here is that you notice here that your leading coefficient is 3. So you have a is equals to 3, b is equals to 7, just the same like the first one, and c is equals to 2. We are going to do the same concept where we're going to multiply our 3 by our 2, and we know that this is going to be 6. So I'm going to put that 6 above, all right? We call this the arc method. Yes, we did use the arc here, but we also use this as the grouping technique further down with the combination of taking out your GCF. But with the arc method, you're going to see something that is going to take place differently. So I'm going to rewrite everything now without the a term. So I'm going to rewrite it as x squared plus 7x. And now what I'm going to do, I'm going to put that plus 6 here. That is coming from that 6 up there. So you notice here, there is a difference off the top. With this example, you first notice that there's a difference with this method in the second line with this method. With the first method, the grouping method, you have to replace with the grouping method, you had to keep your a value and your c value. But in this case, what we did, we replaced the c value with the product of ac, right? And we dropped the a value. So that's what we did in this method. So you have to drop the a value. Now what we are going to do, we are going to find the factors of 6, our AC right here. Find the factors of AC. So find factors of AC, right, which is 6 and 1, because obviously we can't 3 and 2 because that is not going to give you 7. So we are going to choose the first one that we did, which is 6 and 1 here. All right, we cannot choose this latter set of factors. What we are going to do now, we are going to write our factors because now a is equals to 1. So we're going to have an x here and an x here, and we're going to use the 6 and the 1. So this is going to be plus 6. This is going to be plus 1. It's positive because our variable in front of here is positive. Now what we need to do next, we are going to divide by our original a value. All right? Divide by our a. So I'm going to just take, not everything, I'm just going to take this part and divide it by a, which is the 3. And I'm going to divide this by a, which is also 3. So once I have that, now I can say, rewrite as x plus 2. And for this one, because I have x plus 1 over 3, I cannot simplify this, and I don't want to have a fraction in my factors. So what I'm going to do, I am going to simply use my 3 here and multiply it with the x. So I'm going to write it as 3x plus 1. It's like multiplying out something. That's what you have to do. All right. So I now have the 3x plus 1 here, and I have this. And you'll notice now that it is the same answer that you get like the first method. So with these two methods, you can go ahead and choose which of these two methods that you prefer, but it's always good to know them both. You can go back and watch my video on factoring quadratic expression where a is greater than 1, and that is part 1. This is part 2 video. And there was another example that I gave at the end of the video where you can use the cross method. Now that you have learned how to use the grouping method, when a is greater than 1 by using the arc method where you have to multiply a by c and continue with the grouping method. But for the other one, you are using the beginning of the arc method, but you're dropping the value for the a, and you are now simply using the division by dividing each term when you factor it out by the original a. So you can decide which of these two that you prefer, and I hope that you will learn both methods so that when you are given a scenario, you can simply freely choose any one. You show them what you know. Thank you for watching. Please don't keep this video to yourself. If you like it and you want to share it, do so, because I'm quite sure you know of someone out there who needs some help in math. This is a topic in algebra. And once you master this and get ready to go on to algebra 2, which we call it trigonometry, you will do well when it comes to factoring. So please make sure that you understand the concept well and learn both. But if you prefer to absorb one method more than the other, please do so that you can use it to the best of your ability and be successful on that exam. Thank you for watching, and cheers now. See you soon. Bye.